Okay, our next lesson will be about the law of sines. Notice we're going to solve real-world problems again, and since we already have some valuable information about the law of cosines, we now want to introduce you to the law of sines, which I think some of you will even like better, but it's not like you get to choose which one you get to use. It is going to matter about what pieces of the triangles are given versus what pieces are missing. So you can see we're going to find missing parts of triangles using the law of sines. Now keep in mind that we said prior that, let me write it out here in the blue area, that our law of cosines, as a review, needed side angle side or side side side. Those were the only two trig triangle congruencies used for the law of cosines. So that means, take a look here, that the law of sines should maybe use a few more of them. And you knew there was more than SAS and SSS. So take a look. If we have angle, side angle, and angle, angle, side, so that's basically angles, more angles than sides. And then we also give you the side-side angle combination. We give you 3 triangle congruencies that you can use. So you need 2 angles and 1 side in an arrangement combination, or the side-side angle. And now the only part, and that looks a little strange right to me right now, let's see if I can fix it, that if you look at this, that it really is a ratio, a trig ratio we like to call that. And when I look at it, I think I'm going to need a little more spacing here so you can see me changing it. And when we do, you're going to see that the sine of angle C over little c, and remember the edge opposite it has to be the little component. So I'm looking at little c to be right here. And angle A and the side opposite would have little a, angle B, little b, etc., etc. You can see how it's set up from here. So notice in the trig ratio that you will have sine of your angle with your edge that's relationship to it right over each other. Okay, same thing if I have the angle B and its relationship of little b, the angle A and its relationship of edge A. If you look at those, I put the arrows down, they can go either way. As long as you're consistent, sines can be on top or edges can be on top, but it shouldn't be all mixed up. And then the last but not least combination is you only use 2 of these at once. We don't have 3 of them. So it then looks like a proportion, and that's exactly how you're going to solve it. Okay? So you will look at your information based on angle-side angle relationship, angle-angle side relationship, or side-side angle. And if it's one of those, you're going to be able to set up our law of cosines in a proportion style setup. So let's try it on this next example. So I have a triangle here, and you can definitely see by looking at it that it is not a right triangle. And even if you wanted to, you could do the math. So when I say do the math, we've got a 55-degree angle, we've got a 20. So you add those up, and we've got 75. And if we've got 75, that means we only have 15 left to get to 90. And so 15 plus 90, and some of you would say, well, wait a minute, that's 105. So we've got a 105-degree angle up there at angle C that we can now also use if necessary. Okay? So 155 or 155, 105 and 55 gives me the 160 plus 20 gives me the 180. That's my full triangle. But in this case, you can see that we're definitely in need of edge A. So if it's edge A, you have to be using the angle opposite it, the one that cut it out, which is 55. So that's no choice. You have to use the sine of 55 over little a. Now, what's left? Well, you could use the 20 degree, you could use the 105. The question is, which one has their given information? You need the angle and the edge. And so if you ask that, the one that has the information is angle 20. So we're going to say the sine of 20 is to its edge, which was 6. So now we have a true proportion, which means cross products. And if we do cross products, we're going to multiply that way and that way. And we're going to see what our new equation looks like. It definitely should not have any fractions. So ready? A times the sine of 20 has to be equal to 6 times the sine of 55. Oh, okay. You're saying, well, those aren't nice angles. I can't do them in my head. But you can come back over here and say, well, wait a minute. A is my unknown. A is what I'm solving for. Let's get rid of the sine of 20. And we do that by division, which is what we've always done in the past. And when we do that, they will cancel. Our value for A will be equal to 6 times the sine of 55 divided by sine of 20. The only thing is, be careful when you put that in that you make sure the numerator is enclosed and it's all ready to go. So we've got 6 times the sine of 55, divide that by 20 degrees, and we should be at our answer. And our answer should be, as you can see, we got a check down here in the corner, a 14.4 inches. Some of them will be whole numbers, some of them will not. This one is definitely not. So we're good to go with about a 14.4 inches. In the next example, if we say we're in a real world situation and we want this time probably more like a swamp, and we're probably at point Q, and we want to build a walking bridge at RS. But you can see these things are quite long. We're talking kilometers. So right now we're at point Q on the shore doing this measurement with our surveying tools, and obviously they're telling us we need we need edge QR. So QR is going to be that walking bridge, and we don't have that. So let's find it. So if you look at what we have, knowing QR is our unknown, QRs are unknown, you go back across, oh yeah, 42 degrees is the side opposite it. If we look at this again, we have angle, angle, side, and if you wanted to say that, we also have another angle. So you could say we have angle, side, angle. Your choice. So you could add, if you wanted to, the 115 and the 42 up, get your 157, and say, hey, there's only 23 degrees left, and that's what, you could do that. You can do just the arithmetic, but you're still going to have to use the 42 degree angle if we're going to use our law of sines on this one. And so the sine of 42 is to QR, which we don't know. And now ask yourself again, well, which others are given? Well, I could use angle Q if I had its edge opposite it. We don't. I do have angle R, so I'm going to have to use that. So the sine of 115 is to 4.3 kilometers. So again, we are going to have to use the idea of cross products. And remembering that QR is our unknown, so QR times the sine of 115, which will eventually, whoops, don't change your numbers like I just tried to, will eventually have to go away, has to equal the 4.3 times the sine of 42. If we keep working here, then we want to divide both sides by that sine of 115. And again, grab your calculator while I'm finishing the canceling. And let's find out. QR should be approximately, again, I would give the hint on your calculator. Make sure this numerator goes in. You probably wouldn't need this set of parentheses if you had a time sign right here. But you do need to quantify 4.3 times the sine of 42 degrees divided by the sine of 115. When you finish, what'd you get? That's what we're looking for. I know what I got. What did you get? QR comes out to be 3.2 kilometers. Again, a nice rounded, and if it's on a real life problem like this, you would probably have rounded directions so you would know and you wouldn't be guessing about where to round to. Okay, so without further discussion, I think we're set. You now have the law of sines. You have the law of cosines. Both are useful. The one thing you do have to remember is that in the law of sines, it's angle, angle, side. As a reminder, it was angle, angle, side, side, angle, and side, side, angle that you use. So that's what you're looking for. If you just want to remember side, 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 and side, angle, side, because those are easier, are always cosine, and the others have to be law of sines. However you want to do that, but that's what you have to remember. When do I use law of sines? When do I use law of cosines? So work on that, along with getting them put into the calculator accurately, and that'll be two good pieces you could bring questions on to class.